All right, so one of the most important threats that we see is interference, and it's on the rise. And the reason behind this is because of this kind of devices. So these are GNSS jammers, so it's a very small device. We produce like a kind of chirp signal on the GNSS bands. It's very, very effective to prevent any GPS receiver to get a signal. These devices are actually sold, so it's forbidden to use in most of the countries, but you can still buy it. And the reason why we see more and more of these jammers is because information on GPS signal is open, very easy to get. And moreover, the appearance of software-defined radio makes it very, very cheap. So you can build like a transmitter for a very small amount of money. Okay, so the question is, how can we protect our GNSS systems, against these threats? So we think at Spirent it's a three-step process. So first, you need to assess your risk. So you need to get information on your risk, get data on your risk, to be able to then test. So that's the second step. Once you have information, you can test your GNSS receiver or systems against these threats. And finally, once you have this, you can start to develop like an efficient mitigation plan. So for the risk assessment part, for interference, for example, we have a product that is capable of detecting GNSS interference. So it's basically a box with a RF antenna, an antenna, and it scans the GPS, the GNSS bands 24/7 looking for interference, and whenever it detects an interference, it will upload them to a cloud, and then you can get to the cloud and get like a lot of data, a lot of information on these interference. So for example, you know the type of signal, you know when it happens, so what time of the day, what day of the week, and you can get build big data, and you have a very, very good understanding on your RF environment, on the GNSS bands. So once you got this data, you know that's interference, you can test your receiver with against this interference to see how the receiver behaves under such interference. So for this, you can use a GNSS simulator, an interference generator, combine the signal, and you launch that on a GNSS receiver, and you see the results. So how your GNSS receiver behaves. And then the next step after that is to develop mitigation strategy based on that. So there are as many mitigation strategy as issues, but for example, one solution could be to add multiple constellations to your receiver. So if you have GPS, you can add GLONASS, for example, or add multiple frequencies, so GPS L1, GPS L5, GPS L2, and improve antennas. So just maybe move your antenna or change the antenna is also a kind of solution we see. Okay, so I'm going to illustrate that with a use case. So use case of network telecommunications. So for example, small cells on band 42. So a big deployment of small cells. These small cells, according to 3GPP, needs to be synchronized TD-LT on plus minus 1.5 microseconds. So very, very stringent timing synchronization. And this is done through PTP. So IEEE 1588 version 2. So PTP is basically getting time from grandmaster clock that are getting time from GPS. And then this time is distributed to the network through IP and boundary clocks.